This lesson, we're looking at the last bit about friction, about forces and friction. We're looking into friction. So we're adding to the last bit into the forces diagram we learned last lesson. So if you remember last lesson, we were working, the last two lessons, we were working on two things really. One is to resolve the forces, and then two is to use F equals ma. So when do you resolve the forces? So on the normal plane, the axes are going to be like this, a normal axis. So if the forces are not on the line of the axis, then we will have to resolve them. For example, in this force in here, let's say we have F. To resolve this, we're going to draw a right angle triangle and make this as X and make this as Y. And then we can form two using trigonometry or SOHCAHTOA to work out X equal and Y equal in relation to F. So that's the first step. So resolving forces that are not on the axis. And then two, we're going to draw a force diagram. So after resolve X and Y, we're going to draw a big force diagram to put in all the force in X and Y, etc. And then the third step, we're going to use F equals ma on X and F equals ma on Y, depends on the situation. Right. So today we're going to add in one extra ingredient to this formula, to this whole thing, which is the friction. Friction has an equation or formula with F equals, so we use small f for friction, capital F for force, okay, like resultant force, we use capital F. Small f usually means friction. Friction equals to mu times reaction. So mu, so F obviously means friction. Mu is the coefficient of friction. So it measures, coefficient of friction is a number between 0 to 1. 0 means perfectly smooth. So if mu is 0, imagine mu being 0, F equals 0 times anything, then friction will equal 0. Friction equals 0 means no friction. So when mu is 0, it means perfectly smooth. So however, in the real world, there is nothing such that two things are perfectly smooth against each other. So this coefficient measures the material of two things. For example, if you have a rubber on a table, if you're sliding the rubber without the coating of the rubber along the table, you realize the rubber is actually quite hard to slide on a table because there's a lot of friction in between them. Okay, so there's a lot of friction between rubber and the table. So this mu value in here between the rubber and the table will tend to be quite high, let's say around 0.7. Around 0.7. Whereas if you think about a rubber with the coating, with the wrapping on, okay, so in here, and then let me draw a little coating, okay, so there's a little coating next to rubber, and then on the table, you will have a much easier time sliding the rubber on a table because the coating or the wrapper of the rubber will have a much smoother material on the table compared to rubber on its own. So this mu value will probably be less than 0.7. I don't know, I just make it up. 0.3. So it'll be less than that one. So say again, the more friction between, the rougher between two surfaces, the higher the mu value. You can only go as big as 1. Okay, so you can't go anything bigger than 1. It's a coefficient, it's a constant, it's a number. Okay, so right, and R is reaction. So reaction force, when anything on the ground, there's always reaction. So rubber, for example, you have reaction going up, and then we have the weight going down. So that's a reaction. So we can bring a reaction into play as well. So let's have a look in the example below. So F equals mu R, new formula. A block of mass 5 kilograms is pulled along a rough horizontal surface by a by a horizontal force P. So let's draw a diagram. So what's going on in here? So we've got a block of mass 5 kilograms. Then on a block on a table, then naturally you will have the weight 5g and the reaction. Okay, it is pulled by a rough on a horizontal force by P. So let's call it P Newton, because it's a rough ground. If the block is sliding to the right side, then friction will be to the left. Okay, so you will have to determine, use your common sense, even though I probably don't have any, but for now, my common sense is enough for this. you will need friction. Friction is always against the motion. Okay, the coefficient of the friction between the block and the surface is 0.4, so that's the mu value that you need. Okay, so mu equals 0.4. Find the magnitude of the frictional force and the acceleration if the block is 10 Newton. All right, so remember from previous lesson, first step, see if we can need to resolve any forces. Now use a pencil. You'll realize this is the axis. So any force outside the axis, there is none. The P Newton, the R, the 5G, and the F friction are all on the axis, are on the line. So we don't have to resolve any force. So step one, we no need to resolve forces. No need to resolve any force. Now you can tell yourself a reason why. On the next week, you will say because all of the forces are on the axis. Step two, force diagram. So step two, force diagram. So let's put it down again. It's simply, we've got P, which is 10 Newton in here because of P. We've got reaction. We've got 5G. I don't like G. If you know this, 5 times 9.8, that's 49. And left-hand side, we've got friction. Okay. Step three, find the acceleration of the block. So let's do F equals ma in x direction because that's where the block will be moving, right? So on the x direction, we have got 10. Now the block is sliding to the right side. So, well, actually, what we do is we don't do F equals ma in x first. Let's do F equals ma on y because we'll need the reaction, don't we? So F equals ma in y. Now the block is only moving left and right. It is not moving up and down. So therefore, on the y-axis, there is no acceleration. So the resultant force will be upward force, take away downward force, equals the mass times 0 acceleration. In other words, in the y direction is equilibrium because the block is not moving along the y-axis. So therefore, R equals 49, which does make sense because if R does not equal 49, the block will be moving up or down. If R is bigger than 49, which is impossible, means the block is flying off the ground. Okay, it's quite scary. But if the weight 49 is bigger than reaction, which could happen, like in the sinking sand, I don't know, quicksand they're called, I think. So there's you, that's on me. And then if your weight, let's say there's a quicksand, that means the quicksand is pulling you down. So, and then the last will be blue, 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 blue. And then that means the weight in here is bigger than reaction because your weight is sinking you downwards, but the reaction from the quicksand is not enough to support you floating atop. So therefore, it could happen, but reaction cannot be bigger than 49, cannot be weighting then bigger than 49. Anyway, reaction is 49. So, so what do we know about friction? Let's ignore this for now. What do we know about friction? So friction equals mu R. The mu is 0.4. The reaction is 49. So 0.4 times 49, put that in the calculator, is 19.6 Newton. Now, I want you to think about if that makes sense. If F is 19.6 Newton, so what is happening in here? In here, the friction is 19.6, but the pulling force is 10 Newton. If that's the case, what it means is the friction is pulling you backwards. A scary moment. Imagine you in the airport, you try to pull a luggage, okay? You try to pull a luggage. It's like feet, but actually it's not, it's a luggage. You try to pull to the right side, okay, by 10 Newton. However, not only that the luggage is reluctant to move, but the friction is so big that it's actually dragging you backwards. Okay, so you can imagine how scary this is because you'll be like this. And then the luggage is grabbing you by the head. Okay. And then so it's like, so you got 9.6 Newton to the left. Why 9.6? Because 19.6 to the left, 10 Newton to the right. So net is positive 9.6 to the left. So it's impossible, is it? Because friction cannot be dragging you backwards. So what is the friction value in here then? The friction will only be as big as your pulling force. If the friction is too big, that means you can't move it. You can't move it. So no matter how hard you try, you put 10 Newton, it's not big enough to overcome the friction, and hence the block will just not move. So what am I trying to say in here? Question A. So the magnitude of frictional force, okay, so part A, the friction in here will be 10 Newton. I'll give you explanation, okay? Even though the calculation shows F equals 19.6 Newton, friction cannot be greater than the pulling force. So friction can only be as great as the pulling force, but cannot be greater than the pulling force. So pulling force is 10 Newton, therefore friction is 10 Newton. And what do you think acceleration? Acceleration will be 0 meter per second squared. Reason, okay, you don't have to provide it in example. I'm here using green to tell you why, because the pulling force is not greater than friction. Or you can say the pulling force cannot overcome the friction, so therefore it's not moving at all. All right, part B. Now, P equals 50 newtons. That means P is now bigger. So that's okay. So we can do it. So it's moving because friction is only 19.6. So let's do the fourth diagram again. This time with P equals 50 Newton, we have the upward force being reaction, downward force being 49, and the left being friction. So we know F equals 19.6 Newton. So if we use F equals ma in x direction, since the particle is moving to the right, therefore the acceleration, so 50, the resultant force will be the right force taken with left, because otherwise it won't be moving to the right. The fact it's moving to the right means the right force has to be bigger than the left. So 50 minus 19.6 equals the mass 5 times acceleration. Okay, it's probably me, but as a kid, I've always been a right-handed person, and I always feel like right hand is always more useful than left hand. I don't know why. So I think having the right force bigger than left force, it kind of makes sense, but it's not always the case. Okay. Anyway, so I don't know if you have the same feeling as a kid, or if you're left-handed, do you feel left hand is more powerful than the right hand? You always feel like right hand is just useless. It's just an assistance to your main hand. Anyway, 50 minus 19.6, quick maths is 30.4 equals 5a divided by 5 is calculator 6.08 meter per second squared. So it's moving to the right by 6.08 meter per second squared. Okay, next one. So now this example is very similar to the one before that you've done in 5.2. In 5.2, this question has no friction, like a smooth plane. So at the end, maybe you want to compare with that question. That's perfectly fine. This one, we have a friction. So let's have a look. A box of mass 2 kilogram is being pushed up. That's 2 kilogram. Okay. Oops, 2 kg. By horizontal force of 25 Newton, the plane's incline to the horizontal at angle 10 degrees. Given the coefficient of friction is 0.015, that's a mu value. So I like to draw my own diagram because I feel like this diagram cannot satisfy my own drawing need. So let's do this. So 2 kilogram. We've got a horizontal force pushing in 25 Newton. Now, do you remember the 3 staple forces of inclined plane? See if you remember from 5.2. What are the 3 staple forces of inclined plane? Okay, if you remember, try to put them in. If you don't, let's remember it. So it's mg, the mass g, cos theta is 10 degrees, so it's cos 10 degrees. And then downwards here, we've got mg sine 10 degrees. They're always there. And opposite 2g cos 10, we have the reaction. Right? Now, but this time, because there's friction, we have to include friction. It's that new friend in the park. You met in the park. You want to include him, include her to come to your house, or probably not. Do not open the door to strangers. It's being pushed up. Now, if it's being pushed up, think about where the friction will be. Which side would the friction be? Friction will always be a good mom asking you not to open the door, so it will be always against you. So it will be friction. You want to bring your friend Bob to the house, but you can't because your mom, friction, is against you. So it's always against A. All right. So that's the diagram. Now, pair of axes, inclined plane, looks like this. Now, if you count the forces, there are R, 2G cos 10, F, 2G sin 10, and 25. So altogether, 1, 2, 3, 4, 5, 5 forces. 4 of them are on the axis, known as the R is on the axis, 2G cos 10 is on the axis, and 2G sin 10 and friction on the axis. So what's not on the axis? The 25 Newton. If they're not on the axis, what do? Resolve it. So step 1, we need to resolve 25 Newton. I'll put the reason for here again, because 25 Newton not on the axis. Make sense? Right, so let's just draw a pair of axes. Okay, inclined plane, 25 Newton going in like this. We can make a right angle triangle by turning this up. That's a right angle. Now, to make 25 Newton in X and Y direction, think about direction of X and Y. In order to go to right, we must go down on the Y and go up on the X. That's your 10 degree in here. Why? Because of parallel lines. So like a set shape in here. Like a set shape in here, if that makes sense. It's not a very clean diagram. Let me use the color. So like a set shape. Okay, so 10 degree. Anyway, so we can resolve using trigonometry. So if you know your trigonometry, X is not adjacent, so X equals 25 cos 10, and Y is 25 sin 10. Once we've got that, we can then do step 2, which is force diagram. Step 2, the force diagram. Actually, let me move it here. Force diagram. So big one. Now, let's put in the 4 forces that we highlighted before. We've got reaction on there. We've got 2G cos 10 down here. We've got to the left, we've got 2G sin 10. And then we also have friction. Nothing to the right side. So we've got the 4 forces. The 25 Newtons has been broken down into X going up as 25 cos 10. So I use the highlighter to show you this 2 forces. So up, we've got 25 cos 10. So this is the blue. I just color code it for you. So we know X goes here. And then for the Y, it went down. So going down, we've got 25 sin 10. Now, I would not recommend you to remember any of these calculations, because what you should remember is, first of all, remember the 3 staple forces on the inclined plane, and then remember the 3 steps: resolve, force diagram, and F equals ma. The rest of them, trust your maths ability, even though, okay, no, I can, don't be rude, don't be rude. Even though you should be quite confident in your own, don't be rude. So, trust yourself, you are able to pull off the maths in here. So everything in here is the trigonometry. Hopefully it does make sense on the right hand side on the first step. Sorry, I keep using my fingers to point it, but I realize there's no audience when I record this video. You should trust your Sokotoa in here to use the cos and sine in here. Once you've got a force diagram, then you can use your F equals ma in X and Y. Personally, I will do F equals ma in the Y direction first, because chances are they're not acceleration on the Y axis. There will be, but not for now, because the particle is moving along the x-axis. So the particle is moving along here like this. So therefore, on the y-axis, there will be no acceleration. If there's no acceleration on y, that's equilibrium. Equilibrium on y direction. So what can we do? Equilibrium means upward equals downward. R equals 25 sin 10 plus 2G cos 10. Now, what I like to do is I like to put in a calculator, store in the calculator. Right, so let me put in 25 sin 10 plus 2G cos 10 is 23.64. So I'll put it in a calculator and store in a calculator. As a good habit, I'll put little a in there. You can use a pencil. It means I store in a memory box A. So whenever I need R, I'll pull up the number A, the letter A, number A, letter A. English. Next step, F equals ma in the x direction. So on the x direction, now think about which way is the particle moving, is the box moving? Upwards along the slope or downwards? It's important because if you know the box is moving upwards in this case, then we know the upward force, 25 cos 10, will have to be bigger than the 2g sine 10 and the friction downward forces. So therefore, what we do is we'll do 25 cos 10, subtract the downward forces, subtract the total downward forces, 2g sine 10 plus friction equals, so F equals ma, the mass is 2, acceleration we don't know. Next step, what's friction? Friction is mu r. And what's mu r? Mu is 0.015 times our reaction, 23.6. So we can rewrite the whole equation by getting rid of the bracket, 25 cos 10 degree minus 2g sine 10 minus our friction, 0.015 times 23.6 equals 2a. Now we can nicely put them all in a calculator, serve them on a big plate. 25 cos 10 minus 2 times 9.8 sine 10 minus 0.015 times my memory box A. I got 20.862 equals 2a, divide by 2. I got 10.4. I usually round to 3 significant figure in mechanics. So 10.4 meter per second squared. All right. And that's the end of chapter 5.3. Now, if you do get confused what's going on in here, well, I was trying to say, I'll try to tell you don't be, because we'll be practicing a lot in chapter 7. But the main thing you've learned today is 2 things. One, you've learned a new formula, a new friend coming visiting your house, even your mom says no, is F equals mu R, friction equals coefficient of friction times reaction. Second thing you've learned, or sort of recap, is the 3 steps. Resolve 25 Newton, force diagram, and then F equals ma in y and F equals ma in x. That's the method that we use in the forces and friction. Different to moments, we're using upwards or downwards, so we have different structure of working out. If you remember the steps that I teach, you'll be able to do most of the questions. So in mechanics, even the questions are always changing. Myself, when I teach mechanics, I like to give them a structure to follow. Sometimes it will not answer directly to the question, but the good thing in mechanics is you can all answer part A, B, C in all one big working out, if that makes sense. So in here, for example, let's say the question could be, question A, work out the acceleration, and then part B, work out the reaction. But we've worked them all out, okay? So you don't really have to follow what the question say. Just if you know it's a force question, just follow my working out. Step 1, resolve any forces that are non the axis. Step 2, force diagram, and step 3, F equals ma on y and x. Of course, when do you resolve forces? You resolve the forces when you draw the axes. Any forces that are not on the axis that you drew has to be resolved. All right. So that's wrapping up of chapter 5, but we'll come back in chapter 7 again, which is next lesson, and we'll focus a lot more on exam questions. These are just introduction. Okay. Albeit not very nice introduction, but hey, end of chapter 5. Thank you.